Bismillahirrahmanirrahim. Assalamu alaikum, lovely students. I hope you all will be safe and healthy. I welcome you all in my sixth video lecture of chemistry. In this lecture, we are going to start a new chapter, that is chapter number 10. Chapter number 10 is about acid, bases, and salts. The major concepts of this chapter are concepts of acids and bases, pH scale, and salts. Introduction of the chapter is acid, bases, and salts are the three distinct classes in which almost all the organic and inorganic compounds are classified. All the organic and inorganic compounds are classified into three main classes: acids, bases, and salts. The word acid is derived from the Latin word acidus, acidus meaning sour. It means that all the acids are sour in taste. The first acid known to man was acetic acid, that is in the form of vinegar. You know that vinegar is composed of 5% acetic acid. Acetic acid is organic acid because it is carbon containing acid. Hydrochloric acid, sulfuric acid are called mineral acids or inorganic acids. Sulfuric acid is called king of acids. We all have a little concentration of hydrochloric acid in our stomach, and that hydrochloric acid helps in the digestion of food. Acid in rain, when acid mixed with rain, it is called acidic rain. Acid and bases are generally recognized by their properties. Some important properties of acids and bases are mentioned here. The first property, taste. Acids have sour taste, bases have bitter taste. Bitter taste like bitter gourd. Effect on litmus paper. What is litmus paper? Litmus paper is actually a filter paper which is treated with a mixture of natural dyes. Those natural dyes are extracted from lichens. Lichens are a type of fungus. So on the basis of the composition of that filter paper, we have two types of litmus paper: blue litmus paper and red litmus paper. What is the property of acids on these litmus papers? Acid turns blue litmus paper red and show no effect on red litmus paper. Opposite is of the bases. Bases show no effect on blue litmus paper and they turn a red litmus paper blue. Effect on skin. Both acids and bases are harmful for the skin. They harm skin tissues and they cause corrosion, or they are corrosive in nature. Both acids and bases, their aqueous solution. Aqueous solution, aqua I told you comes from water, and aqueous solution means that when we will make their solution in water. So both acids and bases are good conductor of electricity in aqueous solution form. The point that acids turn the blue litmus paper red and the bases turn a red litmus paper blue. This is the tip which we dipped in bases. And this is the tip of the filter paper or litmus paper which we dipped in acid. So acid turns this blue litmus paper red and bases turns this red litmus paper blue. Acids are corrosive. Acids and bases both are corrosive in nature. A corrosive material is a highly reactive substance that causes obvious damage to living tissues. You can see they causes damage to the living tissues. Corrosives act either directly by chemically destroying the part of the skin, like due to the process of oxidation, or indirectly by causing inflammation. What is inflammation? Inflammation means the parts of the body which becomes reddened, swollen, hot, and often painful. So this is the inflamed skin, and this one is the corrosive skin. Acid and bases are common corrosive materials. Acid and bases both are good conductor of electricity, like we have aqueous solution of acid or aqueous solution of a base, and when we dip the electrodes of a circuit and when you turn on the switch, what will happen? The bulb which is connected in the circuit will lit up. So this means that acid and bases can conduct electric current which completed the circuit. As a result, the bulb lit it up. Concepts of acids and bases. There are various concepts about the acid and bases. So the most successful one, or the first successful one, is Arrhenius concept presented in 1887. According to this concept, an acid is a substance that ionizes in water to produce hydrogen ions, and a base is a substance that ionizes in water to produce hydroxyl ions. It means that according to the Arrhenius theory of acids and bases, an acid is a substance which ionizes in solution or which give proton or H plus ions in solution, and base is a substance which ionizes in solution or in water to form hydroxyl ion or to give hydroxyl ion. Examples of Arrhenius acids and bases. First example is of hydrochloric or hydrochloric acid. Hydrochloric acid, when we make its solution in water, hydrochloric acid will ionizes into hydrogen ions and chloride ions. So as hydrochloric acid in solution will give hydrogen ion, so it is Arrhenius acid. Sodium hydroxide, as it contains hydroxyl ions, so when we make its solution in water, it will give sodium ions and hydroxyl ion. So according to Arrhenius concept, the substance which ionizes in solution and form or give hydroxyl ions are called the Arrhenius bases. So HCl is Arrhenius acid because it produces hydrogen ion in solution, and sodium hydroxide is a base because it produces hydroxyl ion in solution. AQ I told you is for the aqueous solution or aqua. Then some substances are mentioned here and we have to identify which one is Arrhenius acid or which one is Arrhenius base. The first one, nitric acid. As nitric acid is composed of hydrogen ions, so it is understood that nitric acid will give hydrogen ion in solution, so it is Arrhenius acid. You can see that nitric acid, when we dissolve it in water to make its solution, in solution or in aqueous solution form, it will give hydrogen ion. So it is Arrhenius acid. Same is for the sulfuric acid. Sulfuric acid is composed of two hydrogen atoms. So it will give two hydrogen ions in solution. So it is also Arrhenius acid. Potassium hydroxide is composed of a hydroxyl group. Ammonium hydroxide is also composed of hydroxyl or OH group, and in solution form, or when we dissolve them in water and make their solution, they will produce hydroxyl ion or they will give hydroxyl ion. So these are the Arrhenius bases because in solution they give hydroxyl ions. Some other important Arrhenius acids are hydrochloric acid, nitric acid, sulfuric acid, and phosphoric acids. Dear students, you can see that all these acids are composed of hydrogen atoms. So as they are composed of hydrogen atoms, so definitely they will ionize in solution and will give hydrogen ions. HCl or hydrochloric acid is used for cleaning of metals, cleaning of bricks, and removing scales from the boilers. Nitric acid is used in manufacture of fertilizers and explosives. Sulfuric acid is used in manufacture of many chemicals, drugs, dyes, paints, and explosives. Phosphoric acid is used in manufacture of fertilizer and acidulant for food. To remove scales from the boiler, you can see in this image the deposition of salt in boilers wall or in the in this pipe wall. This deposition of salts can be removed by using acids. By pouring acid in this tube, though these salts will get dissolved in the acid, and then we can remove that deposited salt from the boilers or from the pipes. Acids are also used for the cleaning of bricks. We have an acid that is a brick cleaning acid, and that brick cleaning acid is used for cleaning the bricks. Acids are also used in explosives. You can see TNT, trinitrotoluene, which is an explosive. So acids can also be used in manufacturing the explosives. Some common bases are sodium hydroxide, potassium hydroxide, calcium hydroxide, and magnesium hydroxide. So you can see that all these substances, they are composed of hydroxyl group, and upon ionization or in solution, they will give hydroxyl ion. So according to Arrhenius as a concept, all these are bases. Sodium hydroxide is used in soap making, hard soap making, also as a drain cleaner. Potassium hydroxide is used in making liquid soap and shaving cream. Calcium hydroxide is used in making mortar, plasters, and cement. Magnesium hydroxide is used as anti-acid and laxative. Calcium hydroxide is used in making mortar. This is called mortar, and this is called pestle. Mortar and pestle are used for grinding at the mostly used in lab for grinding the chemicals, solids, chemicals. And anti-acid, if someone have acidity in stomach, so these are the anti-acid suspension. So when they use this anti-acid suspension, they neutralize the acidity in the stomach, acidity of the stomach. Then calcium hydroxide is also used in plasters, like plaster used for bone fractures. Then limitation of Arrhenius concept or drawbacks of Arrhenius concept or problems of Arrhenius concept are: the first limitation is this concept is applicable only in aqueous solution or in aqueous medium and does not explain nature of acids and bases in non-aqueous medium. This concept we can apply only when we make a solution in water. But if you use any other solvent instead of water, like ammonia also exists in liquid state, and carbon tetrachloride is also in liquid state, benzene is in liquid state. So if instead of water, if we use other solvent, then they are called non-aqueous solvents. In that case, this definition or this concept of Arrhenius is not applicable. Then second drawback is, according to this concept, acid and bases are only those compounds which contain hydrogen and hydroxyl ion. If they contain hydrogen ion, so will give hydrogen ion in aqueous solution. And if they contain hydroxyl ion, then they will give hydroxyl ion in aqueous solution. So what about the other substances which does not have the hydrogen and hydroxyl in their structure? So then why are they acid and bases? Because later discoveries show that carbon dioxide is acidic in nature and ammonia is basic in nature. So how then they explain this? So this is also one of the limitation of the Arrhenius concept. Next concept is about the Bronsted-Lowry concept of acid and bases. Lowry and Bronsted, they were two scientists. In 1923, Danish chemist Johannes Nicholas Bronsted and the English chemist Thomas Martin Lowry, independently or separately, they proposed another theory to overcome the shortcomings of the Arrhenius theory. This theory is known as Bronsted-Lowry theory. According to this theory, an acid is a substance that can donate a proton to another substance, and a base is a substance that can accept a proton from another substance. For example, we have a hydrogen atom and it has one proton and one electron and no neutrons in it. If one electron of the hydrogen is removed from an hydrogen atom, it forms an hydrogen ion. You can see hydrogen atom, and when one electron is removed from it, then we will get hydrogen ion, H plus ion or hydrogen ion. This H plus ion or hydrogen ion, as it has only one proton, there is no electron, there is no proton, so this is called proton. Hydrogen ion is also called proton. So according to Lorentz-Bronsted concept, proton acceptor and proton donor mean this hydrogen ion exception and its donation. So according to the Lowry and Bronsted concept, an acid is a substance that can accept a proton, and a base is a substance that can donate a proton. So in this example, we have hydrochloric acid and water, which will react together and will form hydronium ion. It is also called hydroxonium ion or hydronium ion, and chloride ion. So you can see that in this case or this example, we can also write in this form: HCl or hydrochloric acid gas when react with water will form hydronium ion and chloride ion. From this example, you can see that hydrochloric acid, which transfer a proton to water. So as hydrochloric acid is transferring a proton to water, according to Lowry and Bronsted concept, an acid is any species that donates a proton to another species, or that donates a hydrogen ion to another species or another substance. So according to Lowry and Bronsted concept, as HCl is transferring a proton to water, so this is Lowry-Bronsted acid. And water, you can see that as it is accepting a proton, so according to the Bronsted-Lowry theory, a base is any species that accepts a proton or hydrogen ion from another species. As water is accepting a proton, so according to Lowry-Bronsted theory, it is a base. Another example is ammonia. When react with water, it will form ammonium ion and hydroxyl ion. So according to Lowry and Bronsted concept, ammonia, you can see it has 3 hydrogen atoms, and in this case it has 4 hydrogen atoms. It means ammonia accept a proton. So as ammonia accept a proton, so it is Lowry-Bronsted base. And in this case, water transfer a proton or donate a proton. You can see this hydroxyl ion is 1 hydrogen less than water. It means it donate one of its hydrogen ion. So water, as it donates a proton, so it, according to Lowry and Bronsted concept, it is a base. It is a base. One more example is of nitric acid. Nitric acid, when react with water, it will form hydronium ion and nitrate ion. So you can see in this case, nitric acid will donate a proton and will form nitrate ion. You can see this nitrate ion is hydrogen less. So as nitric acid is donating a proton, so according to Lowry and Bronsted concept, nitric acid is an acid, and water accept that proton and form hydronium ion. So you can see here there are 2 hydrogen atoms, and in this case 3 hydrogen atoms. So this will form the hydronium ion. So according to Lowry and Bronsted concept, water is a base. Now dear students, look at these 2 examples. In the upper example, water acts as an acid, and in the lower example or in the second example, water acts as a base. It means water can acts as an acid as well as a base. So that type of substances which can act either as an acid or as a base are called amphoteric substances. So water is amphoteric in nature. It can act as an acid as well as a base. Example 10.1 classifies substances as acids or bases or as proton donor or proton acceptor. There are two examples. First one is example of hydrochloric acid reaction with water. Second one, water react with ammonia. The first case, when water react with hydrochloric acid, you can see water is accepting a proton and converted into hydronium ion. From two hydrogen atoms, it is converted into three hydrogen atoms. So water, as it is accepting a proton, so according to Lowry and Bronsted concept, water is a base, and hydrochloric acid is donating a proton and then converted into the chloride ion. So hydrochloric acid, according to Lowry and Bronsted concept, is a base. Second example, water with ammonia. You can see that water is donating a proton to ammonia. So water is donating a proton to ammonia, and ammonia has three hydrogen atoms in this case and four hydrogen atoms in this case. So ammonia is accepting a proton. So according to Lowry and Bronsted concept, it is a base, and water is donating a proton. So according to Lowry and Bronsted concept, it is an acid. All Arrhenius acids are Bronsted-Lowry acid except hydroxyl ion containing substances. Other Bronsted-Lowry bases are not Arrhenius bases. Those bases which have hydroxyl ion, definitely they are Arrhenius bases. But if they don't have hydroxyl ion, then it is not compulsory that if they are Lowry Bronsted bases, they will also be Arrhenius bases. Limitations or drawbacks of the Lowry and Bronsted concept is this concept is limited to substances which contain protons. Means that presence of protons are compulsory. If no proton, it means this concept is not applicable on those compounds like substances, boron trifluoride and aluminium chloride. The latest discovery showed that these are acidic in nature, but they don't have proton in them or they don't have hydrogen in them. So they don't have any hydrogen and hence cannot give a proton, but are known to behave as an acid according to the latest discoveries. We have self-assessment exercise 10.1 and question number 5 and question number 11 from the exercise. They are related to these concepts. So these questions are your assignment number 2. The next concept is Lewis concept of acid and bases. G. and Lewis in 1923 proposed a more general, broader concept of acid and bases. According to this concept, an acid is a substance that can accept a pair of electrons to form a coordinate covalent bond, while a base is a substance that can donate a pair of electrons to form a coordinate covalent bond. It means acid is an electron pair acceptor and base is an electron pair donor. In Lewis acid-base reaction, a coordinate covalent bond is formed between the acid and the base. The covalent bond, what is coordinate covalent bond? The covalent bond which is in which both shared pair electrons are donated by the same atom. It means only one atom will donate electron pair. In simple covalent bond, both the electrons are mutually sharing between two atoms. Like both one electron is shared by one atom and one electron is shared by another atom. But in coordinate covalent bond, both the electrons are shared by only one atom. Example is hydrochloric acid when react with water to form chloride ion and hydronium ion. You can see in this case that hydrogen and chlorine, they shared electron with each other, but due to the high electron negativity of the chloride ion or chlorine atom, chlorine will pull electrons from the hydrogen atom. As a result, hydrogen become electron deficient and will get a partial positive charge. To like as chlorine pull the electrons from the hydrogen atom and make it electron deficient. So in order to compensate that deficiency, hydrogen will take electron or share electron with the oxygen atom. You know that the oxygen of the water molecule has two lone pair electrons. So it can share one of the lone pair electron with the hydrogen of the hydrochloric acid. So as hydrogen is accepting electron pair from the oxygen of water, so according to Lewis concept, hydrogen of HCl or complete HCl molecule is Lewis acid. And as oxygen of the water is donating an electron pair, so according to Lewis concept, water is Lewis base. So this hydrogen will attach or will make coordinate covalent bond. This bond is called coordinate covalent bond, in which both the electrons are given by or donating by the oxygen atom. Hydrogen is not participating in sharing of electron. It only accepts electron pair from the oxygen of the water. So this type of bond is called coordinate covalent bond. And while showing the coordinate covalent bond, the tail of the arrow will be towards the donor atom and the head of the arrow will be towards the acceptor atom. As hydrogen is accepting electron pair, so the arrow is towards the hydrogen atom. Another example or the same example, hydrochloric acid when react with water. As I told you, hydrogen, the electrons are pulled by the chlorine atom, and as a result, hydrogen become electron deficient. To compensate the deficiency, oxygen will share its lone pair electron with the hydrogen of the hydrochloric acid. So water will convert it into hydronium ion, and chlorine will evolve out in the form of chloride ion. As hydrogen as chlorine pull electron from the hydrogen atom, so you can see chlorine has 8 electrons. Chloride ion has 8 electrons. So HCl is electron pair acceptor, it is Lewis acid, and water is electron pair donor, so it is Lewis base. Another example is reaction of ammonia with hydrochloric acid. In this case, the same thing will happen. Due to high electronegativity, chlorine will pull electrons from hydrogen and make hydrogen electron deficient. Then hydrogen will share electron or will accept electron from the nitrogen of ammonia, because you know that in on nitrogen one lone pair electron is present. That lone pair electron, it will shared with the, or it will donate to the hydrogen of the hydrochloric acid, and then in turn will form coordinate covalent bond. Again, as I told you that the tail of the arrow will be towards the donor, because nitrogen of ammonia is donating the lone pair, and head will be toward the acceptor. Hydrogen of the hydrochloric acid is accepting that electron pair, and then in turn will form a coordinate covalent bond. So you can see in ammonium ion, 3 bonds are covalent bonds, simple covalent bond, and 1 bond is coordinate covalent bond, which is formed by the sharing of electrons by the same atom. Like nitrogen is donating both the electrons or the electron pair. So as nitrogen utilize its non-pair electron, then in turn it will have a positive charge. That positive charge we will write on the whole molecule on the parenthesis or on the bracket. So as ammonia is electron pair donor, so it is according to Lewis concept, it is Lewis base. And hydrochloric acid is electron pair acceptor. So according to Lewis concept, it is an acid. So, dear students, hope you understand. Hope you will understand this lecture. Inshallah, the other examples of Lewis concept we will do in the next lecture. Until that, take care. Allah.